So welcome to Question Time at Padakshep. Padakshep is a non-profit organization serving meritorious underprivileged students in India. If you want to know more about Padakshep, please visit our website at www.padakshep.org. These Question Time events allows us to not only expose young minds to eminent ones, but also provide the general public an insight into the greatest minds of our times. Today's guest is an expert in the fields of nanoscience and nanotechnology, and the professor in charge of the International Center of Clean Water at Indian Institute of Technology, Madras. He is a fellow of various science and engineering academies, such as the National Academy of Sciences, the Royal Society of Chemistry, and American Association for the Advancement of Science. His incredible contributions to science and society have been recognized with various awards, such as the Shanti Swaroop Bhatnagar Prize in 2008, the Padma Shri in 2020, to name a few. However, despite all such accolades, based on the little that I know him, my guess would be that he would like to be remembered as a great teacher above everything else. With no further ado, today it is my great pleasure to welcome Professor THALAPPIL Pradeep. Welcome, sir.
Thank you.
And
thank you for hosting me.
We have also two co-hosts with us, Nias M, who is pursuing PhD in Germany, and Shivani Mohata, who is doing her doctoral research in India. And there would be few other guests from Padakshep. Welcome all of you. Sir, we will start from your school days. So we know that you had won the National Talent Test Award around 1975-1978. What were your inclinations at that age? Were you predisposed towards science at that time?
Well, I wanted to become a writer because my father was a writer, a poet, and my region had great poets, and in fact a novelist also. Both of them won at Jnanapith. So they are big names in my language. Several of these people used to visit home. Therefore, I used to enjoy poetry, fiction. As a result, it is natural that I wanted to be a writer. To me, language was everything. It was, so if you ask me, when I was a 13, 14-year-old boy, what was the ambition? To play words like, how they play words.
Yeah.
And they were such masters. And words used to, when the appropriate words come to you, you get all the excitement of the universe. And if you get to read the right poem, you get that excitement. Although I didn't know all these at 13, 14, what do you know about the greatness of people? People see, these are all names you see in the newspapers, yeah, but there are people who come home. What else you know about their wisdom? Over the years, I realized that they were all great people.
So, but then you moved to IISc Bangalore for your PhD. How was your experience there? And what made you gravitate towards Professor C.N.R. Rao?
Very interesting question. And after MSc, I realized that I knew nothing about chemistry. And I thought that I should do some chemistry, know a little more about it. Before during this BSc, MSc period, I was not spending really time on studies. I was rather more interested in student politics. went around. I was a public speaker. I was a union activist. I was a writer, of course. I was publishing. So different things. I was a different person. And naturally, I had very little time to go to the classes. Maybe during MSc, I went only for 23 lecture hours. That precise.
Okay, that
So,
sounds something we also had during your classes in 2014. So it was never a forceful, rather it will be like active participation from all sides, like make a fun, like we visited your lab, there is some instrumentation, and see it is like more or less not about a bookish reading stuff. It was more like, okay, discuss and enjoy the coursework and something.
so I did that, and then I realized that I knew nothing about chemistry, so I decided to do a PhD. So I didn't know where to do a PhD, so I went to the university. They said, "Oh, hey, go to Indian Institute of Science. There, you may be able to do a good PhD. Don't do PhD here. Go somewhere else." So I went to Indian Institute of Science, and I was fortunate to get an admission. And then of course, there were several teachers. I happened to work with Professor Rao. Um, then the rest of it, I'm sure that there will be questions on those.
Yes. So, sir, like you, many other students are confused after their masters. They don't know like how to select their supervisor and how to select the research topic. So, in that regard, what advice you would like to give to the aspiring scholars?
I can only tell you about my experience and what I preach. What I preach is what I practice. Uh, to me, the greatest thing in a PhD is to find a good advisor. And PhD is something that transforms you. And that for that transformation to happen, you need to be with that person. Now, it is not the institution, it is not the subject matter, it is not any of those. To me, C.N.R. Rao was director of the Indian Institute of Science at that time, and he didn't have time, naturally. But he would come around 11 o'clock, he would come, running. Hey, are you there? Can we go for a walk? Yeah, let's go for a walk. He will run through the campus, this way, that way, crisscross. It's about 20 minutes, 25 minutes of walk. During that walk, he would talk about everything. Everything about politics, about philosophy, about chemistry, about spectroscopy, his own history, everything. It's like that. It just goes from, he just explodes. And that way, a young man, you also interact with him, all kinds of questions. To me, he was such a great jovial association. Then somehow, with all those walks, the science gradually gets evolved. And he would ask, hey, you have something to write? Yeah, let's write something. Let's have a figure. Let's look at a few figures. The first few manuscripts, he dictated the first two manuscripts, really.
Mm-hmm.
And after that, he never dictated or he never asked me anything. He only asked me, do you have a paper? Please show it to me tomorrow. Then 3 days later, he'll say, hey, here it is from me, take it. That would be the second draft. 3-4 drafts, and that's about it. It is submitted. That's how it used to be. So for me, it was those walks, and in fact, not really walks, runs through the campus, that transformed me.
It's a great pleasure to have you, Professor.
Thank you.
In continuation with what Shivani asked, so we oftentimes see I am doing a PhD now. So I also had, when I joined, a problem of choosing an advisor. But I also saw many people who, after postdoc or after who wants to start a group, has always a problem with how to communicate with students. Right? There is always two sides of the coin. Student has a problem with advisor, and advisors have a communication problem with students. What do you, with all your experience, what is your advice to young faculties or young scientists who are starting a group to use this human capital, or for the students to better have a good relationship? Right?
To me, every institution is nothing but people. It is not about infrastructure, buildings, whatever. It's about people, good people. And if you are surrounded by good people, they will build great institutions. You as a young faculty member, you're part of that institution building process. If you don't realize that, then you are not going to contribute to the institution. The young man or woman who is coming to you is building that institution too. I have a great laboratory.
Yeah.
This lab is not built by just me, it's built by my students. It's their passion. If I don't realize that, then I'm not building the institution. The first thing that I think a young faculty member should realize is that you are part of this co-creation. You are not building, it is co-creation that you are doing. And you are inviting somebody to be part of your family. This young boy or young woman coming to you, you're welcoming that person to your family. And you keep everything open. In my lab, nothing is closed, everything is open. I have only one entry key. And that's how laboratories, in my opinion, to be built. So trust is the second thing, right? The first is you realize who this is. The second is the trust that you have. The third, I would say, what I try to practice, and I have practiced all along, is that this person who is with you, he or she has only one thing, is energy, enthusiasm, intellect. That's all that the person has. The rest of it, the person surrenders to you, right? The whole thing is to you, I mean, chemistry or the subject that you pursue, person surrenders the whole thing. So it is your responsibility to take care of that individual, to handhold this person all through in the best possible way. You may not have a job to give or something. You may not make that person an assistant professor tomorrow, but you have to handhold with this person. I have always taken my students as just me, another part of me. And that's very important as a young faculty member. So this then transmits, then people realize that this man will take care of you. People know this.
Yeah, I will add with this same topic. So just like you mentioned, holding hands. So when I was in IIT Madras, so I have seen like some of your students is presenting in seminar and all. If there is some questions, you think that your support is needed to defend that question. I have seen you to stand up from audience and to defend the questions and all. I have never seen it for other faculties, like standing up and giving an answer to a question like a student. Is it from the same mindset like you used to do that?
Students have to defend themselves. You have to enable them to defend. Sometimes they need direction. Sometimes they need some kind of an orientation. I mean that at the same time, I also mean that when you are at that age, you require a tremendous hand-holding, tremendous support. I have always been treated like a king. I was treated like a king all the time. And I would like to keep my students feel that they should have everything, whatever the system enables. The best of, I mean, when students were supposed to travel in second class, my students always traveled in third AC. I mean, when students had to travel only in third AC, my students traveled in, on plane. They did. But it is important to give them, because they are part of you.
Yeah.
So I think you need to give all of these. So hand-holding goes beyond in many different ways. Whatever you can enable. It's not that you have everything. I'm not Ambani, but you have what you have, you should give.
So you did your postdoctoral research in Lawrence Berkeley Laboratory and Purdue University. What were few challenges and opportunities you faced in the US with regards to research and life in general?
US Berkeley is a place, highly competitive place. Everyone you see plenty of Nobel laureates around, the great people around, and every student is a great student, and their ambition is high. So it is only natural that you are put in an environment immediately. From India, you transform, or you are transplanted into an environment wherein you have to mature super fast. So this transition is difficult. Quick transition is difficult. Now students expect a lot from you from a postdoc. So you have to give a lot of ideas and thought. So this is one challenge. Now, I would say the second is a big cultural shock. For me, I have not lived anywhere else. And so it was the first time that, you go and do everything on your own. You have nobody else. And that too on a postdoctoral fellowship. I was already a father. I was 27 years of age. So it was hard at that time with very limited money and driving. It was not, I was not used to that myself. You live on your meager financial resources. At the same time, satisfying your laboratory, your family, your personal life. To me, together, it was a difficult time. First few months, I would say. Subsequently, of course, things changed.
Okay, sir. Now we will come to a little bit on your research areas and all. So from broader perspective, we understand that it is basically nanoscience and nanotechnology. But how would you like to explain nanoscience to the general audience, those who are not connected with science and all mostly?
Every form of science is about nature, about chemical science in general is about science of matter. Nanoscience is science of matter of small dimensions. It is the science of small particles. As you keep exploring matter at small dimensions, you realize that what you have studied in the past is not the same with such particles. So we tend to explore this more, try to discover new things in that. I explain nanoscience, or the kind of science I do, as an extension of inquiry into matter. extension of inquiry into small matter.
Yeah, also in continuation, if that if we take it a small matter, and then we could usually we can think of electronics or biosystems where you can use such small matters, really tiny things, to make everything small, or to use in biological systems. But what were your thoughts when you started in water purification? So this is not something that is directly related to something being small.
Sure,
Right?
absolutely.
Or like 25 years ago, it was not. Now people can think, but
At that time, people discouraged me, and people told me not to do it. And this is not something that will make an impact. You should work on drug delivery. You should work on better electronics, better data storage, things of that kind. Quite true. But I thought that the new things of new chemistry that we find, if they have environmental significance, we will find ways by which these small particles can be industrially used later. So initially, yes, my interest was on utilizing the new chemistry that I found. But later on, I realized that if at all this chemistry has to be used for people, the materials have to be in manageable shape and size and cost. And that realization took quite some time for me. For a person trained with chemistry, in fact, I was doing gas phase spectroscopy. For a person doing that kind of science, making a ton of material is not easy. I never saw that was possible in my laboratory. But soon this happened. Very soon that happened. It's just that you have to have that conviction to do. You know, I was inspired by people. You know, you have uranium, you need to have uranium in quantities to make a bomb.
Yeah.
But how did people make the bomb? They made the bomb, separated uranium isotopes by mass spectrometry. And that was mass spectrometry. Mass spectrometry is nothing but gas phase spectroscopy.
Yeah.
So you can make quantities through gas phase, just that it has to be massive. That's a big investment. Now, if you were to think that all of these are indeed, you know, they were practiced some time ago, you need to practice things differently. So this was possible. C60 was discovered in the gas phase. And people made that in the solid state. Today we have, right, grams and kilograms and tons of it. So it is possible. So I was quite sure that material science you find at milligram scale or microgram scales can always be scaled up.
So you in the beginning also you had this conviction to go beyond basic science and to go to scale things into industrial or for general use scale.
I would say that when I was a young faculty member, just joined here, I was just 30 when I came to IIT Madras. At that time, I was not sure of. I didn't think about that's the direction to be pursuing. Later, that was 1993. And when I joined IIT Madras, 2003 onwards, 2000 onwards, this work started in water. 2003 onwards, we started making these in quantities. Now, many things helped in that process. So it was around that period that transformation took place. What's the point in giving a patent to somebody? Hey, here is a small patent. This is how my idea is. People here ask me, Professor, do you have a product? Can you show me? So therefore, it was necessary for me to make it into a contraption, a prototype. Therefore, the laboratory went in that direction. Show me an object to which you can relate your science to.
But
So
sir,
anything else? Yeah, go ahead.
it's also challenging, like to make multiple stakeholders together when you are thinking about a prototype. So, and this is
So here, to give you an example, I built spectrometers. So when I came to Chennai, there were no spectrometers that I had with which you could collect data. You could do new science. So I had old some spectrometers. I fixed some of them infrared spectroscopy. I added low temperature to it. So you go to low temperature infrared or high pressure infrared or something, some attachment to it. With that attachment, you could do new science. But I had no spectrometer of myself. So I went to Velachery, some welding shop, some repair shop, some mechanics. I built my own spectrometers. That's how I built my laboratory. And therefore, building was part of me. I would build. If it is not there, I would build it. Therefore, it was not difficult to think about a prototype.
You have made this water technology, very much affordable to the Indians. So basically, I'm at Nadia district, my campus is here, and you must be knowing that this place has a severe problem of arsenic. And your technology, Amrit, has helped many students out here and many people every day. So can you elaborate us a little bit more about Amrit and what led to the foundation of ICCW?
Amrit is a collection of technologies, an umbrella technology, I would say, using new materials to remove contaminants from drinking water and making the water of acceptable international quality, affordably. So I put a condition long ago that my objective is to create affordable water. I called it less than 5 paisa per liter. That was my affordability criteria. Today it is at 2.2, 2.3 paisa per liter. So you need to do material science of that kind. And new materials you design have to qualify this criteria of affordability first. The second, of course, it has to have the sustainability criteria. You cannot recontaminate the soil, environment. You need to also have the energy footprint, carbon footprint, all of those criteria. So today, Amrit is a set of technologies with which we create affordable materials for clean water. My slogan is affordable materials, affordable clean water using advanced materials. That is Amrit. Now you ask, what is new in that in terms of IP? The new thing in IP is to create materials of distinctly different structures, distinctly different properties, so that selectively they capture ions which contaminate water. So arsenic specific material is one thing, or fluoride specific material is something, or uranium specific or mercury specific. New materials we create. And in that process, we have to apply all of those criteria that I talked about. In today, as I went into this, I realized that many people who build such materials, who develop such materials, they don't have a mechanism of translating technologies. So it was necessary to build a place, and that is ICCW. It is a continuation of the same story that I was in a position to do, but my neighbor in another institution is not in a position to do because this mechanisms of translation doesn't exist. Here is a place, come and make it. Come and do it here. So to me, let me illustrate this a little more. For a chemist who makes 2 milligram, 10 milligram material, it is easy to make in the laboratory. But to test anything in the field, you require a kilogram. So you need a pilot to make it, fine. But you may make this 1 kilogram, but you need to translate it to a filter, to a prototype, to something, so that you can test it.
Yes.
And that requires a whole lot of paraphernalia to do. And once you have it, nobody wants to test this as 1 liter of water. To put it in the field, they need to test this for 1,000 liters of water. When you have 1,000 liter of water testing, you need a 10,000 liter storage container. And when it is filtered 10,000 liters, you need to purify and put that water back. You need to have a mechanism. Then this becomes almost like a factory. You need to have a setup. So we were in a position to translate our laboratory or transform our laboratory to a mini production. This we were in a position to do because we had the freedom to do. No money, but we had the freedom to do. And that freedom others may not have. So it was my responsibility to ensure that, or probably give that freedom to others so that they can translate their finding to something useful. Along with that, today there is greater visibility, greater connections. All of these one can offer to others.
So as you have told that what began as a small research in laboratory that you have translated like throughout India, so many people are getting benefited by your technology. So do you have any plans for worldwide implementation of this technology?
Yes, very much. There were, in fact, with that objective, we started a company. And the company starting is easy, as you know, but building that is an issue. There were conflicting interests, and so that activity had to stop at some point in time. But we have started. So now we are testing these implementations in other parts of the world. We're trying one in Cambodia. We're trying one in Kenya. We have tested these technologies and Worth in Australia. We know that these things work in Argentina. We know that these things work in the US. But all of these require much more effort. Material science to translation is slow. Far more slower than other areas. That's the delay there. But this is happening, I would say. Now, I would also say that our mechanisms to translate technologies in India itself is just about a decade old. And therefore, growing beyond is something desirable, but there are, of course, lacunae. See, I'm the only person to have several international patents with other universities abroad here in our structure. You have a lot of international patents, but a joint patent, for example, with another institution, we have still not graduated. We don't know how to do this joint IP sharing. We don't even share IP between Indian institutions. IISc and IIT Madras, if I have to have a joint IP, I have a problem. Now, these are all things I was at least in a position to overcome these. Now, the more these restrictions are removed, better will be the translation, faster will be that internationalization of the technology.
Regarding sir, water purification, we have a question from our Padakshep volunteer. So Orko Santra, he has asked the question, drinking water will be scarce in near future. Countries like Israel treat 90% of its sewage water and make it drinkable. Is India doing enough to treat water which will otherwise be wasted? And second question is, what government initiatives are there on the line of rainwater harvesting?
Great. Both of these are absolutely essential. Let me take from the first thing. Total water on the planet is constant.
Yeah.
And you need to recycle. There is no other way. We get water mostly in the form of rain. Some places we get in the form of snow. But that's all we have, and therefore it is important to harvest. We in the country, we store only 8% of rainwater. Whereas rainwater or water harvesting, many countries are in a position to harvest over 200%. We in the IIT Madras campus, we harvest 100% rainwater. So there is a long way to go, and but then this is happening. As I said, IIT Madras is harvesting. That means in the next door neighbor can also harvest. Tamil Nadu is harvesting, Karnataka can harvest. So this is possible. Technologies are available. We have big companies on this thing, and you can connect with me. Those of you who are hearing, connect with me. So there are a number of people who do this. So coming to this issue of wastewater, we sort of recycle just about, we don't recycle, we treat just about 30% of our wastewater. So there's a huge ocean out there for people to do. There's a big business out there to do. Recycling, very little we do. We treat and then send it to rivers or whatever, that 30% we are talking about, but we need to recycle. Now, this recycle has to be affordable recycling, you see. And when water itself is 2.2 paisa, treated water also has to be of that order.
Yeah.
And this is where new technologies are needed. This is where big sensing is needed. But while technologies, recycling, etc., we say have to be affordable, we realize that the wastewater quality in terms of its input is as complex as in US in terms of the chemicals, in terms of whatever, because we use the same kind of things, right? Ultimately, they all end up in wastewater. So they need to be processed in the same way. But how do you process at a level that is affordable for the country? So those are challenges, and I would say that let's touch upon the last point there. People have evaluated what such a wastewater treatment facility and all that will cost for the whole world I'm talking about. The total wastewater system for a connected world is estimated to cost $60 trillion. And what is India's total wealth? It is $13 trillion. So you can imagine what water infrastructure costs to do it well. There's a huge, massive, unimaginable quantum of money has to go in to this. So that also shows that there is a lot to earn, lot to create, a lot of wealth is out there to innovate.
If we again come back to your ICCW and Amrit projects and all, so generally in research, it takes years, if not decades, to transfer science from lab to real life. Was there any personal life experience that motivated you to start ICCW?
To me, any of these journeys that I started, I found it the biggest asset that I have is my own personal capacity to work hard, capacity to dream, capacity to build. But I also realized that I could do this just because I had a good institution in which I could sit and ask and get freedom. I also had fantastic help, my mentors, my teachers, my students, my support structure. Many don't have it. So it is my duty. So this is that realization that built ICCW. But my own past, I would say, you see, I'm from a village. I walked 4 kilometers one way to my school and through paddy fields, playing with water. And so it was with the puddles that you walk through. Water was around me all the time. And I enjoyed is water pumps. You know, we used to have a water pump, 3 horsepower diesel pump. And I was a mechanic of my diesel pump. I would tear it apart in a few minutes and I would reassemble it back. And it gave me all the lessons of thermodynamics, you know, all the piston and all the rings. And so it gave me that tremendous feeling that I could fix it. I could fix anything. So I was at home, I was the mechanic for everything. But there are a lot of people who don't have this. And you became a mechanic because you could get all of these assembled around you. A lot of people helped you in this process. So constantly you are reminded of this. When you think about your past, you become even more socially conscious and you become more and more responsible. It is quite natural. So for me, these were all the motivations. I wouldn't say this specifically, this is the motivation to do ICCW, but all of these together is, there continues to be, right? I mean, so why are we talking about it today? It's just because I was also a student like you some time ago. I used to do all those interviews. I used to talk to people. I used to communicate to others. I used to take, sleepless journeys, go somewhere and give some small lectures. I travel quite a few kilometers to listen to somebody. A great public speaker is coming. So you went there. So what you are doing resonates very well with me. So it is my duty to help you. Therefore, I come to you. Same is the feeling about ICCW.
Sir, Padek Foundation supported ICCW, what we know. And how were you able to convince Mr. Deepak Padek about your grand vision of this ICCW involving multiple stakeholders from various walks of life?
Deepak Parekh, I went to him and asked him, can you give some money for this objective? He said, I will not give, I can't give. I don't have that kind of money. I don't have that kind of money to give. I said, I need about 30 crores of rupees. If you say that you can't give, where will I go? I mean, this has to be kind of a dream of everyone. You know, dream is all right, but I can't give. I don't have that kind of money. But you see, water is nothing but your business. You see, water is money. Water is therefore banks. Without money, without water, there is no currency. There is no money at all. Yeah, it's all true, but I don't have money. So this argument or this discussion went on for some 10-15 minutes. But then he told me that, I know that this is very important. Therefore, on you, I will give the money. On you. So he said, for you, I will give you 1/3 of the money. That's how it started. I realized that he was only looking for a person to whom he could give such money to, some kind of a charity to. Fortunately, I've been lucky to get several people coming to me, and it's not easy to get money. It's not easy to another person to be convinced that this is for a good cause.
This is great to hear this life journey of transitioning something and also getting funds, right? And with regards to that, so we have some dates written. On January 28, 2018, you had grant support from H.T. Parekh Foundation, and already in June, you started the ICCW. This is only few months. And how did you manage to do, you managed to overcome the bureaucratic difficulties in India? For example, many people have the motivation, they want to do something, but at the end some people at least cannot overcome the bureaucracy. Right? They have no idea. Many scientists.
Sure.
So do you have some nano catalyst?
The key point is, I would say, honesty, your integrity. You go to anybody, tell them that this is what you want to do. And if you are clean, your objectives are clean, you yourself is a clean person, I don't think India is a good country, great country. People trust you. I have started many things with no money, but money came from somewhere. I can tell you one day, I had no money. This was several years ago. I'm talking about 18 years or something. And I wanted some money on this water research. And somebody came here, I talked to him about it. I said, I need about 20 lakhs of rupees. I'm talking about 18 years ago, you remember. He said, send me a piece of paper, 2-page. I wrote that 2-page and sent it to him. 7 days later, I had the money. So it is sometimes, I would say, some divine gesture. Somewhere it comes to you. This is one aspect. Because I have always felt that if your intention is clean, world will resonate with you. But it is not easy to get that. I have not so far taken 1 rupee for my welfare on any of these. That I am absolutely clear about.
So
Yeah, grant rejection is still common, or no?
Yeah, absolutely. Grants get rejected. I mean, I also sit in those committees. Somewhere you have to say no because your resources are limited. I'm so fortunate that in this country, poor country, we get all of this support. Great. But then there are better people than me. They need to be supported.
Yeah.
So you say about,
and our resources are limited. So go ahead.
You say about convincing people and all. So is it something to do your involvement in politics in your college? So management capability or something like that?
Not really. I have those days are all gone now. The most important thing is being truthful to you. You don't say lies. I don't say lies. The only thing that you can be, science is ruthlessly honest. You need to practice that. You say what can be done, you say what cannot be done. You may put it in with all the sugar coating or whatever that you may want to, but you say the truth as truth.
Yeah. So when we discuss about the issues with transitioning from science to really into the general or through industries, so where do you think is the most important contribution comes from, right? From researchers or people who work behind, or from the government, or from the institute? Like you said, institute is a big factor. So where do you think it has a really significant contribution? All of this.
Key in these is to find the right person, the right. We all work with the students. I work with young people. Success of a technology in the field depends on the individual who is ready to work with you. And if you have that individual, I'm willing to give anything that I have to that individual.
I hope many of our audiences will contact you at.
So there is one question from our volunteer also, Tias Basu. So his question is, while most people may know you for your contribution towards low cost and sustainable water purification technologies, I would like to know what inspired you to pursue the challenging problems of astrochemistry, which typically involves ultra low temperatures and pressures. Was it leap of faith from your existing research at that time? How can other researchers be similarly inspired to broaden their own horizons when it comes to their own scientific pursuits?
Beautiful. You can go ahead and do research on water. Let's say take some synthesis or chemistry in water. But anybody else can also do. So you have a great many competitors if you decide to work on water. Well, you say, instead of water, I do this on ice. Then the competition reduces. I say, I don't work on ice at 0 degrees. I work on ice at 10 Kelvin. Then the competition goes down further and further. So this is one way of looking at it. Maybe the other, I decided to look at it as slightly, not because of the competition side of it. I thought there are interesting, whatever science that you do, if it has to be interesting, you need to have experimental capability built to explore that. I have been an instrumentation person. So I decided to build a new instrument to enable a question, enable answering a question. The question I wanted to ask was that kind of new science happens on the surface of ice. Can that science be of relevance? Of course, then astrochemistry or astrobiology comes in. In order to study surfaces, you require ultra-high vacuum. Otherwise, you don't study surfaces in their native state. I wanted to study OH bond in its native state. So I decided to build a spectrometer at 10 Kelvin, 10 power minus 10 millibar, probing that. Now, this whole thought is because of my own upbringing with vacuum technology, mass spectrometry, advanced instrumentation, all of these. I was also curious, and people used to tell me, you can't do that kind of science here. You can't do that. This was a challenge. And to tell people that I can do all that very well here. So you don't have infrastructure of the kind that you can depend on, as in Berkeley or somewhere. Yes, but you can have a Berkeley instrument here, or better. So initially, the first few years, attempts to get that kind of money did not, those attempts were not successful. But then subsequently, people realized that this can all be done, and so we started exploring. Today, we can study surface science at 7-8 Kelvin on ice. We can study OH bond in great detail.
This is very interesting to know all your instrumental importance of instrumentation in your works. And yeah, also in one interview, I remember you said none of the instruments in your lab, so no machine fails, you said, huh? In your lab. But it's so common that in many labs machine fails because researchers are not well.
Very important for people to realize. Let me just take a book. For a long time, people think that idea is science. Idea is science. That's true. Idea is science. Idea is abstract. But beyond idea, thing is science. Thing is knowledge. Not idea is knowledge. Thing is knowledge. Object is knowledge.
Yeah.
Object is knowledge. This is knowledge.
Yeah.
And if you are not in a position to relate idea to a thing, you have a problem. And I have built around me things. Anything that is around an idea, you should be in a position to translate it to a thing. And so spectrometers were such things for me.
And maybe an informal one, do you still involve in taking part in like modifying instruments or?
Yeah, I build instruments. If the instruments are not there, I'll build. If instruments are there, I will buy.
Yeah.
So instruments are essential part of our success. You see, if you don't have the capacity to build, you don't have a barometer. You don't know about pressure. If you don't have that, you don't have a thing, you don't have an idea. You ask this question, this is a chicken and egg problem. What comes first? Is a thing or an idea?
Yeah.
So you have made this water technology so much affordable for the Indians, so especially in a country like us, which is very poor and struggling with resources. So other than water purification, what other challenges you're working now?
This society is full of challenges. I mean, you just walk, just look around, you have challenges. But unfortunately, your lifespan is so limited. Your own resources are limited. So I tell people about all kinds of challenges, all kinds of ideas for others to pursue if it is possible. In my laboratory, I pursue, so I help others to discover, in different areas. But in my laboratory, we work broadly around water, but not only purification technologies, but also about sensing in terms of a product, marketable thing. But don't get me wrong, I work on my 20% of my science only goes there. I have this 80%, whether I work on this ice or whatever else, I work on different themes. They maybe some of them are blue sky, but to me they all connect. They all connect to water in some way. For me, it is, I can see that connection. For others, they may not see that direct connection. Everything enriches my work, my translation. So it's not that you work only, on water. if you have to work on water, you may have to have some amount of biology, as I said, some amount of instrumentation, some amount of electronics, some amount of sensing, some amount of prototyping, and some amount of management, some amount of finance, some amount of philosophy. All of these is there. So you need to work on all of them. Our time is very limited. No, so your time is so limited. What are the things that you work on? I work on things that challenges me.
So as you told, like initially the cost was around 4 paisa per minute for Amrit technology, but then you have brought it down to 2.5 paisa to 2 paisa. So how do you make it so affordable?
Yeah, it is something that there is no magic formula on this. You have to break this into several units where all the prices comes in, affordability comes in. You invest your effort in that. At the same time, it has to be acceptable to our own people, former students. They should get a respectable salary from that. Nobody is working on charity. And they should get a respectable return. It is a complex thing, I would say. But any cost, you can break it into several units, and we work on each of them. Now, can you make it even cheaper? I'm sure it is possible. As you keep expanding further, you realize that many of the investment that you have made in the past will help you in reducing it, reducing the cost lesser to a lesser value. I don't have to invest that much on research today, research infrastructure today, because I have already created. I do not have to spend that much of time today to rediscover old materials because I know them. On the process engineering side, I don't have to reinvent because I know them. I do not have to invest too much on marketing because I know that market. So as I keep going, I suppose if these technologies were to go to another country, we are at a much more advantageous position because we have this great Indian experience. So that is how, I think these are the ways by which cost will come down. But materials cost by and large globally will remain the same. The cost of gold is the same, right? The same way cost of iron or aluminum or something will be the same.
Niyas, once you were saying something about Sir's achievement about Kerala Sahitya Academy, just
Yeah. Yeah, I am also from Kerala.
Oh.
I am from Kochi.
Oh, okay.
Yeah.
Good.
So
Great.
maybe we will move from science a little bit. So you
Yeah.
had received the Kerala Sahitya Academy Award, right, for popular books in science. So what are your other interests than doing research, like writing books, and what is your motivation? And also one last question, that what do you consider as your greatest achievement so far, from yourself?
Well, let me speak about Malayalam. Writing in Malayalam was part of my upbringing. I'm a Malayali. Language is like your mother. It is not like your mother. Language is your mother. This is true of all languages. I love Bangla so much that as a student, I read all the novelists there. Whether it is Vibhuti Bhushan Bandyopadhyay or whoever. So it is fascinating to read. And I used to write poetry years ago. But one thing that is missing in Malayalam, great language, is quality science writing is a problem. popular science. So therefore, when there is a possibility, I write popular science. And I had 10 days of a break when I was sort of a research visit to Japan, 11 days rather. I decided to write a book on nano, and that won that Sahitya Academy Award. So that was serialized in Madhrubhumi. This became a book, and then that is how that award was, award came that way. Now, writing is something quite within you. I mean, as far as I'm concerned, it is part of my existence. But you have to nurture it. I chose this popular science, but one could write, if I were to be in Kerala, what would I be doing? I would have probably written more and more. But today I'm doing science because this is how my world became that.
Do you have something now at present?
I need to
something
write
going
about
on?
my own experiences of doing science as a in India as an Indian researcher.
That in Malayalam?
So maybe you can write in English.
Malayalam.
Yeah.
Not Malayalam, but it is something that has to be done for everybody, I think.
Yeah.
Indeed.
So this, in a way, this is something important for people. What did I do? That was the second question that was asked by Nias.
Yeah.
What is that? I think in my own evaluation, my science is expanding. More and more quality science is happening. Great things are coming. So it is yet to come. This is one feeling that I have. But what did I do? What is that I feel as the greatest satisfaction for me?
Yeah, exactly.
Past, let's say 29 years, I would say around me, you can smell science at IIT Madras. That's a great satisfaction. Around me, there is an environment of science, environment of quality, environment of something that I wanted to feel and experience. That's what I think a youngster can see.
Okay. Sir, a last question from our Padakshep student. So his name is Joydeep Sarkar, and Joydeep has a question. Sir, in your life, what goal and or ambition did you have from a young age? That is first question. Second question, sir, how much or what type of hard work was involved to reach so far? And then I will come back to third question when you finish those two.
Okay, ambition. What did I want to become? I wanted to become someone purposeful with my life. As I said in the beginning, I wanted to be a writer. But then I realized that I knew nothing about the subject that I chose to study. I wanted to study that more. And I realized that soon I realized that I will be a professor because that is what I enjoyed most. And so I used to say at that time that I will be a professor. I knew that I will be a professor. This is what I wanted, and this is what I have become. In the initial stages, it was not clear to me. But it took, maybe about in the middle of PhD time to know which direction I will be. Now, what was the second point that was
So how
asked?
much and what type of hard work was involved to reach so far?
You know, it's this is the only thing I do today. It is Saraswati is a very difficult goddess to satisfy. It keeps asking more and more, more and more, more and more. And you have to burn yourself. So what is that you have given? You have given everything. I have given everything that I have. So people ask me, do you have a house at that, whatever, when I was a professor? No, I don't have a house. I thought I can buy a house anytime. You have a car? No, I don't have. I can buy a car anytime. But I never invested my time into any of these. I invested my time only in this. I invested my money in it. I invested my time in it. I invested myself into it. But then it is not my success or something. I should say, for me, my wife sacrificed herself. She simply burned herself for me. And for me, people around me, they have burned themselves. You see me, but around me, there are a lot of people who have burned for me.
Yeah, so third question is, sir, on the same line itself, that, sir, given that you have been so successful, what is your motivation now to pursue new research, or wake up in the morning and do the research again? Okay, go to lab and pursue, and that what maybe for all the researchers like us, or maybe new PhD scholars, or for everybody, that what should be?
Research is a continuous journey. Just as any creative job. Let's say you are a novelist, writer, musician, a dancer. You have to do it every day. And if I don't do it, then I have a problem. I cannot live without writing a few sentences, few pages every day. I cannot do that. Without giving a lecture, I cannot feel that my life, my day has been fulfilled. This is my life. This is my way of living. People ask me, what are you? Who are you? Well, you don't have to ask this question or talk to me for a long time. You just see me for a few minutes. You see my environment. You will know that I am a scientist. There's no question. This is your life. Now, for you to live, you need to do science. For a musician, you need to sing to be purposeful. For a dancer, you need to dance to be purposeful, right? This is what has become to me. It has taken a long time to realize that. It's not that I don't do science as a job. I do science as my life.
Okay, sir. On this note, we'd like to conclude our discussion, I will say. Today, sir, on behalf of Padakshep, I would like to thank you for your time and sharing your valuable life experiences and insights. And we hope that you succeed in all your quests, especially to provide clean and affordable water to everyone across the globe. And we also hope that you join us in future events and support us in our endeavor to serve meritorious and underprivileged students in their pursuit of education. And lastly, we would also like to thank our co-hosts, Nias and Shivani, for their participations, and others as well, Gaurav. Thank you, sir.
Can I make a final remark?
Please do.
It was very great to have this opportunity for us. And also the answers are so great, very interesting. So I hope that the smell of science that you talked about will reach beyond IIT Madras and to everywhere in the world. And this is what, so also through the audience of this interview, the smell of science, I hope this will reach everywhere. Thanks for being here.
Thank you.
Thank you.
Thank you, Nias. So thank you, all of you. Yeah.
Thank you.
Shivani, Subendu.
Thank you, sir.
Thank you.